What's up guys, welcome back to the channel. Today on this video we'll be deriving the following polynomial that you see here. Now I made two videos where I derived two polynomial functions. Go and watch that videos. Those videos, uh, they are very fun. They will appear at the end of this video on the playlist. But then if you are returning to the channel, you can pause and try to solve this problem, and let's see if you're gonna get the same answer as the one that I'm gonna get at the end of this video. And if you're new to this channel, all I can say is subscribe to the channel, because I've made lots and tons of videos on mathematics, and also I've made videos on trigonometry, I made videos on limits, I made videos on expansion, also made videos on other derivatives. So you can go to the playlist section and select the videos that you want to see or the topic that you want to watch. All right, let's start guys. As you can see, this polynomial here that you see here, there's a certain things that we need to simplify first before we differentiate. Now let's look at our problem there. Now as you can see, let me first highlight here guys. As you can see, the first term, we need to identify what function is this. Obviously this, it is sec, it's a trigonometric function. And what about this one here? This one, as you can see, x is an exponent. It means this is an exponent. Be very careful guys, before you differentiate. You need to identify first the type of function. And now let's look at this one here. This one here is a natural logarithms, so you have to be very careful. And this one here, it needs to be simplified. And this one, honestly speaking, I can already tell it's a standard derivative, but you will see as we simplify, because there is a certain law that you need to apply here in order for you to simplify this one. All right, let's continue guys. Let's continue. Let me just move this thing a bit. All right, so let's simplify. So when we simplify, we know that we're gonna have 1 over 4 and then sec x. This one is already simplified, but this one here, we need to get rid of the suds. Remember, I always tell you guys, try to get rid of the suds, change them before you differentiate. So we know that square root is the same as exponent of half. All right, and then here, this one, there's no need for you to get rid of it because there's no x under the square root, so you can rewrite it as it is. Okay, some of you might try to change this 3 square root 3, but don't, because we don't have x there. So the x is actually on this one, but we can also change this one here. Now there is a law. Let me first write it first. There is a law guys that goes like this. When you have, okay, let me explain this law guys. Then let me explain what I just did here. How did this came about? Because some of you might be confused how this came about. There's a law from logs. Remember, logs, they have the same law as the natural logs. So let's say we have log a base b, log b base a plus log let's say c base a. Now the final answer, if the base are the same, you can write this log like this: log base a and then b multiplied by c. This law, by the way, this is the law. This law is the same even for natural logs. If you have maybe natural log a plus natural log b, you can also write it like this: natural log and then a multiplied by b, or ab. So guys, this is very important. So this is what I did on this one here guys. This is what I did here for this one here. Be very careful guys when you solve this one, because it's easy to make mistakes there. Okay, let me just erase that. So you can go to your logs and try to remind yourself when it comes to logs, the laws. All right, so now let's do the last term. Now the last term also, it has laws, guys. Now let me remind you again, reminder, right? Let me just remind you again. Look, this is a law. This is a law. Do you still remember this law when we have something like log? I say log base 10, right? I mean, if we have 10 and then we have exponent of log, let me just use a different base. Let's say we have 2, right? And then we have log, maybe let's say we have a base 2, and then that is x. If this base here and the base on the log are the same, the answer is going to give us x. So if you look at our log here, remember, if the base is not written, this is going to be 10. We know that if the base is not written, this is going to be 10, and this base here is also 10. So our answer is going to be this 2 here, guys. That is the one of the log laws. Go and check it out when you check the log laws. So after simplifying this, now let's continue and simplify here, guys. All right, let's continue, guys. We have y is equaling to the first term is fine, it's already simplified. Rewrite it as it is. I always tell people, do not differentiate before you fix every term here to be in a standard form. Now when you look at the exponent here, we have, okay, the base is 2. When you look at the exponent, we have 8x, and then the outside exponent is half, so they will multiply. So what is 8x multiplied by half? You're gonna be left with 4x, right? So this one, we have to remove the bracket. If you remove the bracket, you're gonna have root 3, and then we have natural log, and then 2 plus, oh, minus, because we still have this root 3 is negative. It's gonna be root 3, and then we have natural log, then x plus 2. Now as you can see, we're no longer having 1 2 3 4 1 2 3 4 terms. We actually now have 1 2 3 4 1 2 3 4 5 terms because of this natural log there, guys. From here, this one here, guys, is our function at the standard simplified function. Everything now is fine. We can start deriving here. All right, now let me just do some line here so that I can write the general formulas for deriving, guys. Okay, now let's start with the first one here. So dy over dx. Now let's look at this first term. The first term here, let me just do this. The first term here, as you can see, is a trigonometric function. So when we write this standard formula here, remember, if you say y is equal to we have 1 over 4, which is gonna be our k, and then we have sec. Okay, all right, we have sec, and then we have x. We don't have n because there's no coefficient of x there. The dy dx of this one here, it's gonna be as follow. It's gonna give us k. First of all, we're gonna have k, then we're gonna have sec x multiplied by tan x. So as you can see, this is our dy dx of this problem here, or that term there, guys. Okay, this term here, that is a dy dx. So you're going to substitute this dy over dx on the first term. Now before we start though, you need to know what is k. K in this case for the first term is going to be 1 over 4. Guys, I repeat, if you don't know where we got these formulas, I made a video talking about these formulas here, guys. So go and watch that video so that you can understand. But if you did, it's fine. You can just continue watch these videos here. Okay, now let's continue, guys. Let's continue. So when we substitute k is gonna be 1 over 4, right? And then we have sec x, so it's gonna be sec x, right, multiplied by tan x. So this is what we have here. So this one we just derived it. Now what about the second term? Now we have negative 2 to the power of 4x. This, guys, is actually the exponent function. So we are deriving where x is exponent. So we need to write the general formula for this one. So let's write it here. We know that if we have y, now we don't have k, so we can say a, and then we have n, though, the coefficient of x, and then we have that. And then when we find the dy over dx of this one here is gonna be n multiplied by a, and then we have n multiplied by x, and then we have natural log, then base a. All right, so look, guys, we need to look at our function here. As you can see, the base here is 2 and is 4. So let's just write it here so that when we substitute, we know exactly. So n is gonna be what here? N is gonna be 4, and then a is what? A is gonna be 2. So when we substitute this part here, when we substitute this part here, we're gonna put 4 where there is n, and we're gonna put 2 where there is a. So let's continue, guys. Let's continue. All right, remember we have minus there, so this is going to be minus or subtraction. And then when you look at this formula here, we have n, and what is our n? Our n is 4. All right, then multiply, and then we have a. What is our a? Our a is 2. And then what is our n? Is an exponent. Our exponent is 4. And then we have multiplied by x, and then multiply by natural log base. So a here is going to be 2. So that is that, guys. If it so happen again you don't know where this formula is coming from, go to the icon there, go and watch those videos. I explain exactly how to use this formula here. Okay, now let's continue. Let's go to the third term. So this is a third term. As you can see, let's look at the third term, guys. Let's pay attention. The third term is root 3 natural log 2. As you can see, there is no x here, guys. There is no x. Remember, we are deriving in respect to x. There is no x on this one. So if there is no x, don't waste your time, guys. This is gonna be 0. So rather write this 0. Okay, there is no x, so it's 0. Now let's move to this term here. Let's move to the fourth term. Now the fourth term, we have root 3 natural log x. This time we do have x, so the answer cannot be 0. Now if you still remember, let me write the general formula for this one. If you still remember, when we have y is equaling to, now we do have k this time around, k, and then multiply by the multiply by natural log, and then x. Then if you want to find dy over dx on this one, we know that is going to be k, then multiply by the derivative of natural log. We know that is 1 over x. Always, guys, do not forget this one. It's easy to forget this one, by the way, so do not forget it, guys. Right now we know what k is here. Our k is negative, in fact it's root 3. Okay, let's look at this. Our k this k, this is our k here, it's the coefficient of the function. This k here is root 3. So I hope you can see, guys. Now we have to substitute this formula here when we find the dy over dx for this one. All right, let's do it, guys. Let's do it. So remember, we have some minus here, so it's gonna be minus, and then what is our k? Our k is root 3 multiplied by 1 over x. As you can see, it's k multiplied by 1 over x, and our k is root 3. Now let's look at the last one here, plus the last one. If we pay attention to it, look guys, we don't have x here. This one is similar to this term here. There are no x's here, so if there is no x, basically the answer is 0. Don't waste your time, guys. We are deriving in terms of x. Now let's continue. So our dy over dx for this one is going to be 1 over 4 sec, this one already is fine, guys, sec x multiplied by tan x. All right, so this one here, it's also fine like this, guys. Don't be tempted to multiply this 4 with this 2. This 2, it has the power of 4x. This one is the power of 1. So please do not multiply this. Write it as it is. So it's 4 multiplied by 2x to the power of 2 to the power of 4x, and then multiply by natural log 2. That's it, nothing more but that. So we know that this is 0. You don't write 0, we can say minus, and then we say 3 root 3 multiplied by 1. This is going to be root 3 multiplied by, let me just close here, divide by x, and then this one is 0. So final answer is this one here, guys. Okay, I hope you managed to see what is happening here, because there are a lot of rules that you need to understand in order for you to solve this problem. And when you simplify it, it's simple to make mistakes here, guys. This is the final answer. I hope you understand how we came about this. I didn't mention this, guys. For this formula, again, you can go to the top here and watch the video here to explain this formula here. Okay, but guys, if this video did manage to help you to understand, do not forget to like, subscribe, and also comment if it so happen that there's something that you need to share. And you can share this video on with your friends so that they can able to have advantage as well. Thank you very much, guys. Until next time, see you.